So in this video, we'll be talking about how we can divide polynomials and specifically using the long division method. So recall from elementary school that you can divide two numbers using long division. So for example, we have 5 and 2. We can divide this out with long division. So we have, so our 5, our numerator is our dividend. So this is our dividend. And the 2 in the denominator is our divisor. And so we put the dividend under the division symbol because that's the number that's being divided, and 2 on the outside, which is the divisor, which is the number that's dividing the 5. So we do 2 times 2, 4, and we're left over with the 1. So this 2 here is our quotient. And then the 1 left over down here is our remainder. And so we could say that 5 over 2, when long divided, gives us 2 plus a half, or we could write it as 2 and 1/2. Same thing. And so this idea of dividing numbers by using long division, we can apply this idea to polynomials. So we can divide two polynomials, general form, say f at x over some divisor d at x. And so let's go ahead and do an example, and I'll show you how we can long divide polynomials. So let's say I want to divide. So I have my thing set up here. So I'm going to put the polynomial that I want to divide. So I'm going to put 2x cubed minus 7x squared minus 7x plus 19. And we're going to divide this by x minus 1. Okay, so how do we divide these polynomials? Well, it's very similar to how you would do two numbers. So, what do I have to multiply x by to get 2x cubed? Well, that's 2x squared. And if you can't just think of that in your head, well, you can think of it as like this. So you have 2x cubed, and you're dividing it by x. Well, if we divide this out, the x cubed and the x reduce to x squared, and the 2 just remains. So we have to multiply x by 2x squared in order to get 2x cubed. So we're going to put 2x squared. And so we have 2x squared here. Now we have to multiply the 2x squared by the 1 as well, negative 1. So we have to multiply by that as well, which would give us negative 2x squared. Now we're going to subtract this like we would subtract two numbers. So negative 7, let's see, so negative 7x squared, I'll just put the number. So negative 7 minus negative 2. So we have to be careful about that. The symbols can be tricky when we're doing this polynomial long division. And that's equal to negative 7 plus 2, so negative 5. So this is negative 5x squared minus 7x plus 19. So now what do I have to multiply what do I have to multiply x by to get negative 5x squared? Well, that would be negative 5x. And again, you can think of it as like this. So 5x squared, negative 5x squared, and x is dividing it. So the x squared and the x reduced to just x to the first degree, and the negative 5. So negative 5x is what we have to multiply x by. We get negative 5x squared. Again, we have to multiply negative 5x by negative 1, which gives us positive 5x. Again, subtract everything. This gives us 0. Negative 7 minus 5 gives us negative 12x plus 19. So the 19 carries down. We'll put a little arrow for that. And then, so now what do I have to multiply x by to get negative 12x? Well, just negative 12. And now I have to multiply the negative 12 by the negative 1. So I'll get positive 12. Again, subtract these will cancel out. And then 19 minus 12 gives you a remainder of 7. So now our division is complete because we can no longer multiply anything by our x minus 1 term to get 7. We can't multiply anything by x in order to get 7. And so our division is complete, and this is our remainder. This is our remainder. And so you can see that we applied this concept of long dividing numbers to long dividing polynomials. And so we have a very similar situation where we had a dividend, which was this number right here. We had a divisor, and now we have a quotient, and we have a remainder. So we could write this as we wrote this part over here. So we could say that when 2x cubed minus 7x squared minus 7x plus 19 is all divided by x minus 1, we get 2x squared minus 5x minus 12 plus 7 over x minus 1. So this is our remainder over the divisor plus our quotient. So in general, we can write any division statement as, and I'll use this part here, so I'll just use this. So we can write our general division statement as when we divide two polynomials of the form f at x over d at x, where we get something of the form q at x for quotient plus some remainder r at x over d at x. And that would be our our division statement. And then obviously you can cross multiply things to isolate for other quantities. So we could multiply something like the divisor, and in order to isolate for f at x, or you could isolate for r at x, or you could even isolate for q at x. And also, if the remainder is equal to 0, then this would just reduce to f at x over d at x equals q at x. And that's pretty much all for long dividing polynomials. In the next video, we'll be looking at how we can divide polynomials using synthetic division.